Hello friends, welcome to this video in which I will take you through the concept of measurement of credit risk. I have already prepared a video on the concept of credit risk. So in case you want to understand what is credit risk, you may watch that video. The video is posted on this channel itself and you can run a search to find that video. Why is it that I'm mentioning about that video? Because if you go through that video, it will be easier for you to understand the measurement of credit risk concept. So in this particular video, I will take you through two broader concepts that you need to know. One, expected loss, and second, unexpected loss. So let me briefly discuss with you what are the key drivers of credit risk, because unless we do not know what are the drivers of credit risk, it will be difficult for us to understand how the unexpected and expected loss can be calculated. So there are four main drivers of credit risk, as you can see in this particular slide. First is the default probability, or probability of default as we call it as. The second thing is loss given default, which is what I will discuss in detail as we go ahead. Next concept is exposure at default, and the last one is the maturity. Now maturity can be part of probability of default concept itself, because I'm sure you would be aware that if a loan is given for longer period, which means that loan has a longer maturity, the probability of default can be higher. Similarly, the exposure at default is a function of time frame. So that is something which we will discuss as we go ahead. But as of now, just to clarify that when we calculate expected and unexpected loss, we will have three broad concepts: PD, which is probability of default, which is listed here. This is the first concept. Then loss given default. Then we have exposure at default, which is the concept here. And finally, what we are going to discuss indirectly is the maturity concept. Maturity will not be directly visible in the formula that we work on. So let's start with what is probability of default. So probability of default is a statistical measure, okay, which quantifies the likelihood that a borrower will default during the entire future period. That's how we look at it. But this future period, if it has to be defined, we can define it for a specific time frame, which is 1 year. So as you can see in the definition is saying very clearly that what is the likelihood that a borrower will default. Okay, that's what we call as probability of default. And default does not necessarily lead to immediate loss, but may increase the probability of future default and resultant losses. So every time when a borrower defaults, it may not result into a loss. Sometimes a borrower defaults and then the loan becomes normal loan also, because the borrower recovers. Okay. Let us take a simple example to understand. If somebody has a job, he had a loan and he fails to pay that loan because he has lost his job. Now that's a default that has happened. The borrower has not paid. He may not pay, he or she may not pay for a long time, say 3 to 6 months. And after that, you know, the loan may get regularized. Okay, so every time when there is a default, the default does not mean that there would be a loss, but definitely the likelihood of loss increases when there is a default. So we have just discussed the concept of probability of default. Now what are the features of PD? First thing that we have to understand is that PD is never zero. Does not matter who is the borrower, you don't take PD as zero. One exception could be that when there is a sovereign, okay, or when there is a government which has borrowed, we say that the PD can be zero, which is technically correct. But there are many examples, okay, which have established so far that even the government defaults, right? So we cannot assume it to be always true. Okay, uh, you have to think that there is a likelihood that even government may default. So some governments, or rather many governments, classify their debt as low risk. They don't say nil risk, because remember one thing, the government's ability to honor the commitment on its loans or on its bonds is definitely infinite, in the sense that the government can print currency and honor it, but practically speaking, we don't assume that the PD should be zero. Okay, the PD could be very low, and that is what we should think logically. Of course, when it comes to the risk weight assignment, sovereign which are rated AAA, okay, their risk weight is zero. But if all sovereigns are not rated AAA, so even government can default when it does not have a very good rating, right? Second thing is that PD increases with time. PD is a function of time. That is what I was saying in the previous slide also, that when there is a probability of default, it will be higher with a longer time frame and lower with a shorter time frame. I mean, if the loan has to be repaid in next 30 days, it's easier to establish whether the borrower will default or not compared to say 30 years, right? And as I've already mentioned, even governments may probably default. Having looked at PD, we must know how PD can be, what are the methods through which we can measure PD, right? So we can use a method like credit rating matrix, okay? It's nothing but a transition matrix which shows the probability of a borrower's credit rating migrating from one rating to another, which means, you have a AAA rating as a borrower and the rating changes to AA or vice versa, which is AA to AAA. That is something which we call as the credit rating matrix. Okay, so credit rating matrix may show different behaviors. It may stay in the same credit grade, so you stay as a AAA borrower. It moves up, which is AA to AAA. It moves down, okay, which is AAA to AA, that example that I gave you, and there could also be a default, right? So this is something which, you know is a useful insight, especially basis the historical data, to predict whether a borrower will default or not default. So what has been seen is that a borrower which is rated AAA, okay, historically, has a very minimal likelihood of defaulting in next 1 year. That's very less, right? So that's your credit rating metrics that we need to know. The next point is cohort approach. Through cohort approach also we can predict probability of default. So cohort approach is a static method where you take a group of borrowers, which is cohort, okay, track them over a fixed period of time and count how many default happened during that time. That's called as the cohort approach. So cohort approach can also be used for predicting probability of default. There can be duration approach. So duration approach counts all rating changes over the course of the year and divides by the time spent in the starting rating to obtain the migration intensity, which is finally transformed into a migration probability. That is what happens with the duration approach. Let me give you an example to explain this. So you can see here that we have the following data for a group of loans starting the year with a rating of A. Okay, so what you find is that there is different behaviors of this loan. No change happens. Okay, it downgrades to B, it defaults. Okay, uh, there is a survival and upgraded to AA, right? So all these are situations which are there, right? So if you look at these situations, what do? You sum the time spent in rating A. So how much time was spent in rating in one particular rating, right? So we can see that one loan has 12 months basically for the period of staying at that. Four loans had again 12 months, okay, where they stayed for the same rating, right? So what we do is we take the sum, or we rather sum the time spent in rating A, okay, count rating changes, which is the migration that has happened, okay, calculate the migration intensity through a formula, and then finally transform intensity into probability. That is how we use the migration approach. So migration approach also helps us to kind of predict the probability of default. Having looked at probability of default, we move to the next concept, which is called as exposure at default. So if you recollect, in the beginning we had seen that there are four key data points that we need. One, PD, second LGD, third EAD, fourth maturity. So we have discussed PD, we have now come to EAD, or exposure at default. So exposure of default is the total value a bank is exposed to when a borrower defaults on a particular loan. So if you take a loan, okay, your loan exposure decreases as you keep on paying. Please understand this. you took a home loan or a mortgage, as some people call as, for 1 million, okay, which is 10 lakhs, and you keep on paying that mortgage. So as you pay, the principal amount outstanding reduces, because of which exposure at default also reduces. Okay, so it represents the expected outstanding balance at the moment of default. So when you default, how much is the balance left is nothing but exposure at default, okay, including any drawn amount and possibly some portion of undrawn amounts. So many times what happens is that there are loans which are not fully drawn. Okay, there could be an undrawn amount. Okay, so what we do when we calculate EAD, we take into consideration current outstanding balance, which is what we will do in case of normal loans. Okay, and credit conversion factor into undrawn amount. Okay, so what we will get is we will be able to find out, okay, what is the total amount of exposure at default that we have in a particular loan. So we need to take into consideration outstanding balance plus credit conversion factor into undrawn amount. Okay, so what is undrawn amount? Undrawn amount is the approved limit minus current uses. Okay, there are lines of credit where you have an approved limit, like a cash credit. If you take a cash credit, there is an approval, say for 50 lakhs, but you have only used say 30 lakhs, right? So what will happen is that we will have to uh, look at this amount, which is undrawn amount, okay, and then we will have to multiply it with the credit conversion factor. Now credit conversion factor is a factor which is given by the regulators, and it is different for different lines of credit. So these two will together give us what is called as the value of exposure at default. Now, having learned exposure at default, we go to next concept, which is called as loss given default. So what is loss given default? Loss given default is nothing but, it measures the percentage of a loan that a bank expects to lose if borrower defaults. So every time when there is a default, as we discussed earlier, there is not full loss. Some amount may be lost and remaining amount may be recovered, right? So whatever is the recovery, 1 minus recovery gives us loss given default. So if recovery is 80%, that means loss given default is 20%. If recovery is 100%, then there is no loss given default. So we have three concepts of PD, LGD, and EAD that we have discussed. Now using these three concepts, what we can calculate first is called as the expected loss. What is expected loss? It is the average loss that the lender anticipates over a certain period due to borrower's default, and it is a function of three things: PD, LGD, and EAD. Now what is PD? PD is just probability of default, so it comes in percentage, say 20%, just as an example. What is LGD? LGD is nothing but loss given default. So that is also in percentage, which means the loss given default could be 50%, 40%, 30%, 20%. And then there is an EAD. EAD is an amount. Please do not forget this. So first two are percentage and third is the amount. Now EAD is the outstanding amount. So when you multiply PD, LGD, and EAD, you will get a value called as expected loss. So let me give you an example. If your loan is of 5 million or 50 lakhs, okay, your probability of default is 50%. So first you multiply 5 million, which is your EAD, with 50%, which comes out to be 25 lakhs or 2.5 million. And suppose your loss given default is 10%, okay, then 25 lakhs or 2.5 million into 10% will give you 2.5 lakhs, okay, or we can say that this is how we calculate expected loss. Now how do we calculate unexpected loss? So unexpected loss is nothing but it represents the potential variability around the expected loss, okay, which means when you calculate the expected loss, you are not sure whether that exactly will be the loss that you will incur. So there is a variability or standard deviation around that which we need to calculate, right? So unexpected loss helps us to calculate a loss that could occur due to worse than expected default. So every time the loss is not expected default, it could be more than that. So how do we calculate it? We calculate it through a formula which says EAD into, and then we have square root of PD into LGD square, okay, and then we have the remaining part of the formula which has been listed here for your reference, right? So this gives us what is called as expected loss. So what is the total loss that you have? The total loss is nothing but expected plus unexpected loss. That is how we calculate this, right? So I have given you a brief understanding of this expected and unexpected loss. I hope you understood this concept. these concepts rather. In case you need any help, please do write to me on healthofmywealth@gmail.com. Thank you.